Well, g'day, Max here again, and welcome back to the shop. So this week we're going to step back and readdress a couple of the oiling issues in the compound slide and cross slide on the lathe, because I think we previously mentioned our oilers had turned up, so we get all that sorted out, done, boom, finished. We do the groove, the oil groove in the underside of the tailstock, which I completely forgot about, never even give it a thought until, as I said last week, Doug Lester mentioned it from Metalworks Machine Shop. So I did splash out and buy a couple of little things, a set of hardness testing files, so at least that'll give us a bit of an idea of some of the materials that we're playing with. And this was something different. Brought it cherry red. This is case hardening compound, so you can get your mild steel part and you heat it up cherry red with the oxy. You roll it round in this stuff, it gets a coating on it, and you heat it up again with the oxy, and then you quench it. So that's one method of getting a case hardened or case hardening done on mild steel. So that will come handy for something. Don't know what, but we'll find something. So, well, summer's arrived early here in Perth. It's kicking our butts at the moment. So we're hovering around 39, 40 degrees. It's for this time of year. I think it's broken all records. I think since 1931, the weatherman said today. So, yeah. Okay, well, let's get into these last little jobs on the lathe. Okay, the other job we have to readdress, because our oilers have now turned up, is this oiling system that they have for the compound slide. Now, if you recall, we'd already cut an oil groove in the gib strip for the compound. So we'll flip this over and I'll show you what happens, or what our plans are. So their oilers here and here. All they do is deposit the oil in this area here and this area here, not on the ways where it's required. So we'll turn. So there's the other side of their oilers, one there and the other one. Oh, there it is. Oh, the hand's in the way. There's the edge of it there. So yeah, they're just putting the oil, cooling it on top here, which does nothing. It's a waste of time, I think, anyway. So what I'm going to do is, on both sides, I'm going to drill through. I'm going to put an oiler here. We'll cross drill, pour it through here, and then we'll just machine a small groove in here with a ball nose cutter, and the same on the other side. And the gib strip side, which is this side, we'll just put a little drilling through the gib strip. So it will be in this area here, and link it to this oil groove. Okay, we've got our compound set up in the mill now. We're just going to do a simple slot down one side and down the other side as well. Now these slots will run diagonally and end up from one side across to the other. Just got a 6mm ball nose end mill in there, and we're just running the Bridgeport at 1500 RPM. We're just eyeballing all this in. Cut up another couple of thou. A bit of zero, set our height dial at 0 so we can come up the same height on the other side. Okay, we're ready to slot our second side now. Now this vise I'm using has a swivel base, so all I'm doing is I've got two set points, 4 inches long for the slot to be, also 2 inches either side of the centre drilling, and I'm just swivelling the vise around and eyeballing the edge of the cutter to the edge of the part on both the extremities of the oil hole. Now when the cutter crosses through the centre of the oil hole there, it's not necessarily going to be in the centre. It's not really, it doesn't have to be as long as it cuts through it, because the angles of the slots are different, because this way here is narrower than this one, but this one also tapers wider at this end than that end due to the gib strip. So that's why we're just eyeballing them. So here we go. Zero mark. They're looking good. Okay, so we can get them deburred now and clean the part up, fit our oilers and put it back together. Okay, now we have the gib strip refitted in its pretty close location to where it will end up after a test fit on its mating slide. So we just have a couple of parallel toolmaker's clamps and a dowel, or a sander drill and a dowel because we have the angled face on the gib strip. So what we're going to do now is drill through our oil port all the way through the gib strip. Okay, so hopefully now there's our port coming through. So all we have to do is link that hole to that groove just there. Okay, so the oil will flow through from the oiler through this hole at the rear of the gib strip. It'll travel through the gib strip and come out this side here. So I'm just going to use the Dremel and just break through into this oil channel that we've milled in here. And once the oil comes through, it can travel along the length through these oil channels here. That'll give us proper lubrication to the dovetail slide. That's all it took. Just had to break away that corner so the oil can travel either direction. So I'll get all this cleaned up and put back together. This will be a blanking slug for our oil hole. Okay, we've got our blanking slug in place there. So what that will do, when we put our oiler back in here and we pressurise this oil cavity here, the oil will come through here along this slot and into our zigzag ways, or zigzag oil grooves along those ways here. What was previously happening, you'd lose all the oil pressure out of this hole and it was just dumping the oil on top of the slideways where it does nothing. So now we get pressurised oil feed to this way. So all that's left on this is a cross drilling through here and an oiler in here, and we'll drill through our gib and fit the oiler. Okay, so I was just thinking about this a bit more with this extra oiler, and I'm not going to put the extra oiler in the side. What I'm going to do is I'm going to pick up off our oil passage that we drilled through here. So I'm going to cross drill below here, through here. That way it will still be fed from the single oiler. So if I drill through there and clamp the gib underneath and drill through into the gib, this one oil point here will do pressurised oil to here, and it will also send pressurised oil to the gib. So I'll do that way, and then that's one less oiler we have to do, as the one oiler here will do both faces, as does this one here. So we'll get her set up in a drill and drill our cross hole, and then I'll tap it and I'll put a small blanking grub screw in, same as what we've got here. So. Okay, we're through. Okay, we have our gib strip oil port through there now. So we've picked up successfully on our cross hole, and you can see there the oil port goes straight through the gib and picks up on the, where are we? Hole here, which I've just relieved the edge of the hole with the Dremel, so it picks up on the oil groove. Now, because the gib moves up and down in relation to the oil port in the back, we've just cut with the Dremel a small slot, just extending on either side of the hole, so as the gib moves past the oil hole, the oil will still always flow through the hole due to the slot. Okay, one other little annoying issue with this lathe is the grub screw here for the cross slide lock. Now this is just an ordinary grub screw going in against the gib strip, and once again, where are we? Here we are. It's like those hollow point grub screws meant to grip on the shaft. So what this does, because the grub screw contacts the gib strip at an angle, well, if I look end on, it would actually be like that. So what happens, it causes these, try and get it in the shot, these little gouge marks just here in the side of the gib strip from the point contacting at an angle. So what we're going to make is a little adapter between the grub screw and the gib strip. So we've just machined down a small piece of steel. It'll fit neatly in the hole, and we'll just mill a 60-degree angle on it so it will push squarely against the gib strip. Okay, so we'll just deburr that, part her off in the little lathe, and that will allow the locking screw to contact squarely with the gib strip. I just slow that down a tad. You gotta love parting off in these little lathes. Totally amazing experience if you've never done it before. Especially when they've got worn headstock bearings. That's better. There it goes. Okay, so that's our little slug. We'll get that in the cross slide, and that'll allow the locking screw to tighten up squarely against the gib. So we have our flat edge at the back and the 60-degree edge on the other side. Okay, we're coming to the closing stages when we're looking at the tool post. We're actually going to give it a clean out. I've popped one of the pistons out, so it's just all you do to pop the pistons out, these retainers, they just pull straight up. There's a spring behind the piston, so you pull the retainer up and the piston and spring comes out together. So what I'm going to do with this one, this has provision here for a cap screw to screw it down to the compound slide to lock it in position when you're doing any heavy cuts and that. So I'm not going to do that. I'm going to draw it through and make a pin that drops into the top of the compound there. So that will, I've had trouble with this moving before because I do a fair bit of turning with 4140 and pre-hardened and case hardened steel bar, and it does put incredible tool pressure on. So anyway, we'll get this drilled and a pin machined up. Reason we use cutting oil there because this drill is a really neat fit in the tool post body, and this is hardened, so that's only cast iron. So, but just to help the drill get through the hardened part, it was only a few thou it was taking out, so should be good. No. A few noisy neighbours over the back there today. I think one of them really loves the sound of his own voice. I guess that's what happens in suburbia. Okay, so we have lift off our post. Okay, we've got a nice neat hole, precision fit hole now, so we'll turn up a pin. It'll be a nice neat fit in the hole and a nice neat fit through the tool post. And that will lock it solid in position so it can't move.